Hello, welcome to our college algebra notes. We're on Unit 3, Outcome 7. It's our second to last set of notes. Like I told you in the last set, we are changing topics here. We're done with exponential functions, logarithmic functions. The last two sections we're going to cover, we're going to deal with solving what we call systems of equations. A system of equations when you have multiple equations and multiple unknowns. Today we'll stick with just two unknowns and two equations. And then outcome 8 will cover what happens when you have three different unknowns, and we'll see that you have to use three equations. There is a rule that if you have multiple unknowns, you need at least one equation for every unknown, one distinct equation, I should say, for every unknown in order to be able to solve it. Now, before we really get into solving these equations, we just want to look at what a solution for a pair of equations like this looks like, and how to check if something is a solution. So, since there are two unknowns, in this case x and y are both unknown, we have two unknowns, we will have answers that will be ordered pairs. So they're going to be pairs of numbers because we have to need a number for both x and y. They do put these in alphabetical order, or kind of the typical order you're used to when you're graphing. So we will put x first and then y. So this is x, y. So by writing this ordered pair 5, 2 as a solution, they're asking, does it work to make x equal 5 and y equal 2? If that works, then yes, it's a solution. Now by works, I mean if we plug these numbers in for x and y, does it make both equations true? Now it's not good enough just to make one equation true. These pair of numbers have to work for both equations. So we're going to check them both. We always have to check both. Because if you only check one, that's not adequate. So we'll check the first one. We're going to plug 5 in for x. We're going to plug 2 in for y. So I get 5 plus 3 times 2. And that should equal 11. If it does equal 11, then it's true. And so far they're working out, but we got to double check. So 3 times 2 is 6. 5 plus 6 is 11. And so far, so good. It checks out in that first equation. We have to check both, so we also need to check the second equation. Let's plug 5 in for x. That's 5 times, replace y with 2. So we get a 2 in there. And see if that gives us 15, if this is going to work. 5 times 2 is 10. Plus 5 is 15, and so it checks out. So this ordered pair, this 5, 2, 5 for x, 2 for y, it works in both equations. So yes, 5, 2 is a solution. Now we haven't necessarily guaranteed it's the only solution. It is possible for these to have more than one solution. We'll see that later. But we have guaranteed that 5, 2 is a solution to this equation. If you're looking just for a solution, or if you just want to know if that's a solution, then yes, 5, 2 is a solution. It is a solution for this pair of equations. We'll do one more. That's the idea. If you ever get a problem answer, especially if you're doing like a multiple choice question on an exam, you want to make sure that the answer is right. You can go back and plug it in and see if it works. So let's try one more. Ordered pair this time. They give us 1, 5. So we're thinking x is 1, y is 5. And again, we're going to plug it in both equations, and we're going to check them both. So I check the first one, plug 1 in for x, 5 in for y, so I get 2 times 1 for x, plus 3 times 5 for y. And we see, does that equal 17? Does it work? 2 times 1 is 2, 3 times 5 is 15, 2 plus 15 is 17. So it checks out. It's working so far. I don't want to check the other one. So we put 1 in for x, plus 4 times y is 5, so we get 5 in there. And see if that equals 16. Well, 4 times 5 is 20, and 20 plus 1 is 21. Does not work. So we can see that no, the second equation does not work when you use 1 and 5. As soon as one of the equations doesn't work, then we can say no. That ordered pair is not a solution. Now, that doesn't mean there is no solution. There is possibly a different number that could be a solution to this pair of equations. But this one's not it. 1, 5 is not the solution. This is how we can go back and make sure that the number we got is valid. If it's not, if our pair 1, 5 doesn't work, this doesn't work out, then no, we can say 1, 5 is not a solution. Okay, so that's what we do to check our solution. So if you have an answer, you want to make sure it's a good answer, you go back, you plug it in to see if it works. Now, how do we get the solution in the first place? Well, there are actually a few different methods. We'll cover multiple methods. But the first one is going to be the substitution method. So the substitution method, the trick for the substitution method is you always want to solve one of the equations for one of the variables. Which equation and which variable does not matter. So we're just going to solve for a variable. Doesn't matter which one, so we'll solve for a variable. And if you're lucky, it's already done. In this case, it's solve for y. That's already done, so we don't even have to do any work. We don't have to solve for y because it's already done. And then what you do is you take that, whatever y is equal to, and you replace that stuff for y in the other equation. So we're going to plug this in. We're substituting it. That's why it's called substitution. Substituting 3x in for y, because y is the same as 3x. By substituting that in there, so substitute this 3x in for y, we end up with an equation, x plus 3x equals 4, that only has one kind of variable in it. So it doesn't have both x's and y's. So the other equations, both equations originally had both an x and a y, So you couldn't just solve for one of the letters and get the final answer. But by getting an equation with just one kind of variable, now you can just solve this for x and find out what the value of x is. So now we're going to solve this for x. So we're going to combine like terms. X plus 3x is 4x equals 4. Divide both sides by 4 to get rid of this 4 on this side. We get x equals 1. So now we actually know the value of x. We know x has to be 1 because y has to be equal to 3x, and so we can replace y with 3x because they're the same amount. And this equation has to be true, otherwise the substitution, the ordered pair doesn't exist. So we have to be able to solve this and find this true solution. And we found out x equals 1 makes it true. If you plug 1 in there, it is true. Now once we know what x is, once we got that, we got to go back and figure out y, because you need both parts, right? You don't just want the x, you also want to know what y is. So we're going to take this, we're going to plug it back in. Since this equation is already solved for y, the equation we're going to use. You could plug x into either one. It does not matter which equation you plug it back into. I'll go ahead and use this one down here because it's easy to plug it in there. You could just replace that x with a 1 and see that y needs to be 3. Now if I wanted to double check, I'd put 1 and 3 back in there, and you can see 1 plus 3 is 4, and then y is 3, x is 1, and 3 equals 3 times 1. So it works in both those equations. So we could see the answer is the ordered pair 1, 3. Your answers, you'll want to write them as ordered pairs. I'm not really picking on the exam, so if you put x equals 1, y equals 3 on the exam, I'm going to be fine with that. I'm not going to be worried about the ordered pair, but on my lab, they'll ask for that ordered pair. So make sure you're giving them the ordered pair for your answers. Again, always the x value first, y value second. I have seen some problems where they kind of end up with you're solving it, and you end up with y on the left and x on the right, and people just switch them around. They forget to put the x first and the y second. So don't mess that up, because if you put 3, 1 instead of 1, 3, that would be wrong. I have to take away points for that. Okay, so that's the idea. Substitution, you solve for one of the variables, and then you substitute that into the other equation, and then solve for one letter, and then plug that back in to get the other letter. So let's try it one more time. So again, this one's a nice one for substitution. You can always identify an equation, problem where it's like, oh, substitution is going to be the method to go to, because you can see that one of the letters are by himself. As soon as you see that, you're going to take all that stuff that it's equal to and substitute it in for that letter. So we're substituting it for y in the other equation. So here we end up with x plus, still a 3 there, right? There's still that 3 there. But that 3, instead of just being times y, is going to be times all this stuff. So we have 3 times 2x minus 9. I'm putting in parentheses here because all that stuff has to be multiplied by 3. Okay, so now I'm going to go ahead and solve this equation. Now that it only has x's in it, we can solve for x and we can get the first part. So I'm going to distribute 3, because by distributing I can get rid of the parentheses. 3 times 2 is 6x, 3 times 9 is 27. Don't forget the minus, and don't forget the plus x equals 8. Next I can combine some like terms. X plus 6x is 7x. Now try and get x by itself. So first off, let's get rid of this subtraction. Let's add 27 to both sides. Get rid of this thing. So we get 7x equals 35. Divide by 7 on both sides. So divide by 7 here and here. Get rid of the 7 here. We get x equals 5. All right, so we figure out the value of x. Again, once we figure out one of the values, we're going to plug that in. Again, it doesn't matter which equation you use, but I'll probably use the bottom one in this case because it's easier to solve for y, because it already is solved for y. So put 5 in for the x, and then we'll see what y is. Well, 2 times 5 is 10, so we get 10 minus 9 equals y, so y is equal to 1. And there's our answer. Our answer is the ordered pair of 5, 1. And again, if I want to double check that, I plug 5 and 1 in there for x and y and see if it does actually make the equations true. It should make both equations true because the way we've done it should give us a good answer. There's no risk of false answers doing it this way. You're going to be guaranteed got a right answer as long as you've made all your steps correct. Okay, now these can be a little messier, so you can get some of these where you want to do substitution and it might not be quite so easy. So here's a messy one just to show you what it can look like. First thing you'll notice is this is not solved for any letters, right? There's no y by itself, there's no x by itself. And so before I can do any kind of substitution, I'm going to have to simplify a little bit. I'm going to have to take one of these equations and solve it for one of the letters. So now it doesn't really matter which equation and which letter. You can kind of do whichever you want. So I'm just going to try and pick one. So I think, let's see, let's do the second equation. We'll solve this one for y. Now, if you're really tricky, you can kind of look ahead and maybe figure out which one's going to be easier to solve for which letter. You know, if you're really kind of planning and stuff. But no matter what, if you just solve one of the equations for one of the letters and then plug in the other equation, you should eventually be able to get the problem solved. Okay, so I'm going to go ahead. I'm going to try and solve for one of these letters. So I'm going to go ahead. I'm going to get y by itself. So I'm going to subtract the 3y across. That way I get all the y's on the same side. So get rid of this thing. So if I get all the y's on the same side, I get 2x plus, well, this just becomes y, because 4 minus 3 is 1, so just one of those y's. So it's 14. Now y, you can see why I picked this one, because y is going to be easy to get by itself, because all I have to do is subtract 2x across. So subtract 2x across, get rid of this part, and we get y equals 14 minus 2x. So I kind of picked that one, because I thought it was going to be pretty easy to get y by itself. Idea is, once you do that, once you get one of the letters by itself, you can take that and plug it in. Now, don't plug it back in the same equation. Now, usually that's easy to avoid, but in this case, it might be pretty easy to take this and I'll plug it in for y here. But that's the equation we started with. You want to make sure you use the other equation. So at this point, we're going to plug it in for y there. So I get 2x minus 3 times 1. Instead of y, I'm going to put 14 minus 2x. So 14 minus 2x. Equals 8 minus 2x. So I did all that, replace the y here with 14 minus 2x. That's how I got this. Okay, next step, I want to get rid of these parentheses. I'm going to go ahead and distribute. Distribute here, get rid of these. And I get 2x minus, so 3 times 14, that's 30, plus 12 is 42. 3 times 2 is 6, but a negative makes a positive, x. Now I can combine some like terms. I got 2x plus 6x, so that's 8x minus 42 equals 8 minus 2x. Let's get all the x's on the same side. So I'm going to add 2x to both sides. Add 2x here. So get rid of that minus 2x. While I'm doing this, I'm going to go ahead and get the numbers on the other side. So I'm going to add 42 here. Add 42 here. Get rid of this minus 42. That way on this side I have 8x plus 2x gives me 10x. Over here 8 plus 42 is 50. So now I'm ready to divide by 10 on both sides. Get rid of this multiplication. So I just get x. And 50 divided by 10 is 5. So we got the x part. As soon as we get the x part, we can go ahead and plug it back in. Now you could go back to any of the equations you start with. It will work. You can plug 5 in for x and solve for y. But since this one's already solved for y, that's probably where I'm going to go. I'm going to plug 5 into here because that's going to be easiest. So we get y equals 14 minus 2 times 5. Now it's really easy to solve for y. So 14 minus 14 times 5 is 10. So minus 10. 14 minus 10 is 4. So my answer is 5, 4. I'll just put that as an ordered pair. 5, 4. You can see it got to be a lot more work when they didn't start out solve for x. In fact, this one's really bad because not only does it not start solve for any of the letters, it also didn't even have just one of each letter. We could have simplified this right off the bat, maybe adding 2x to both sides in the first one. I'm subtracting 3y across on the second one. So a lot of times you could maybe, if there's stuff like that, you could simplify the expression before you start trying to solve it. But this is just an example of showing you that substitution always works. It's not always the easiest method. In fact, sometimes people avoid this method because it's not as easy as the next method. So the second method, and either of these methods can be used all the time. So you can always use whichever method you want. I'm never going to tell you to use a specific method. The homework sometimes will say use this or that. I don't care. You can use whatever method you want. But this is the addition method. Now, the addition method came about because eventually someone said, solving these system of equations, it's not that bad, but man, it'd be nice if we could just take the two equations, line them up, and do addition like we did in grade school and get an answer. And then someone else said, hey, I think that actually works. That's kind of what the addition method is. The addition method, we're going to add them all, we're going to line them all up. So we're going to line the x's up, the y's up, the numbers up, even the equal sign. All that stuff is lined up. And then we're just going to treat it like grade school addition. We're just going to add the rows, the columns up. So we take x plus x, we get 2x. Y plus negative y, you can see those ones cancel. We just get a nothing there, right? Plus 0, because positive y, negative y, they're opposites. Bring down your equal sign. Bring down your equal sign. And 1 plus 3 is 4. So we really don't need the 0, right? That's just nothing. That's nothing, 0. So we just get 2x equals 4. Now we can divide both sides by 2. Get rid of this 2. And we get the answer x equals 2. So guess what? It works. The addition method works. You can actually line them up. Just make sure everything's lined up. You have to have everything in the same columns. But if that's done, you can add it up and get an answer that way. Now, I should say, a little warning, this only really works if one of these things cancels. So you saw how the y is canceled. So I always get students on the test where they try and do this addition method, but nothing cancels, and so it doesn't work. So I'll talk about that later. How do you deal with it if nothing's going to cancel? But I'll do a couple where it does cancel first, just to show you the easiest one. Now we're not done, of course, because once you find x, you have to go back and find y. Now in this one, since we didn't solve anything for y, we don't really have a preferred one to put it in, so we can just pick whichever one we like. It doesn't really matter. I'd probably just go with the top one because it's got positives, and that's usually a little bit easier to work with than negatives. So go ahead and put 2 in the top one. So for x, so I get 2 plus y equals 1, because I plugged 2 in for x. I'm going to subtract 2 from both sides. So get rid of this 2. You get y equals -1. So there's our pair. Now this is the problem where someone on their homework does this and they put in the answer -1, 2. They go, wait a second, you gotta be careful. Remember, x comes first, y comes second. So your answer should be 2, -1. If you put that in the wrong order, if you put -1, 2, you got it wrong. Because again, the first one's always x and the last one's y. So you want to make sure you put the x number first, the y number last. So this is the one where people mess it up. You know, it's something where you're just going quick. It's easy mistake to make. Okay, let's do one more addition method. Again, we're doing addition. We're just going to add them up. And then again, because I picked a nice one, stuff will just cancel, right? You can just see the 2x minus 2x, they just cancel right off the bat. You know, this gives us nothing, 0. 3y plus 6, 3y gives me 6y. This might get 6 plus -6 actually gives me 0. That's okay. You can get 0 there because it's okay for one of the letters to equal 0. In fact, that's what happens here. Divide by 6 on both sides to get rid of 6. And you see that y is 0, right? 0 divided by anything is 0. It's the other way that's messed up. You can't do, you know, if you put 0 on the bottom, that's where it's undefined. But 0 on the top's okay. This is just 0. So y is 0. Now we're going to go back and figure out what x is. So again, I'm going to pick either one of these equations. I'll go with the top one. 2x plus 3 times 0 should be 6. 3 times 0 is just 0, so that's 0. So I get 2x equals 6. Divide by 2 on both sides. I get x equals 3. And that's our answer. So our answer is 3, 0. So we just put 3 in for x, 0 in for y. So if you have this, if you have them where they're all lined up, you know, the way they should be, x's, y's, the numbers, the equals, everything lined up where you want it. And if stuff cancels, the addition method is really slick. And you can see why I'd much rather do it this way than having to sit here and solve one of these for x, one of these for y. Especially because this one, if you try and solve for x or y, you end up with fractions. No one wants to work with fractions if you don't have to. So it's just so much easier to do it this way. Now let's try one addition method where it's not set up quite as nicely as we want. So it is lined up, right? We still have x's, y's, and numbers. So that's nice. The problem here is if I were to add these right off the bat, I do 4x plus 2x, I get 6x. I do 3y plus -5y, I get -2y. And you see if I try to add these right now, nothing would cancel. So note that nothing cancels. So the trick here, the method to make this work, is to take and multiply to make it so something cancels. So we usually just look and say, okay, is there a number I can multiply this by that makes so one of the letters will match? So if I look at the x's, you can see that if I have the bottom, if I double the bottom, I'll get another 4. And if I multiply by -2, I'll get a -4. So that way when I add 4 plus -4, they will cancel. So what I'm going to do here is I'm going to take this whole bottom row and multiply by -2. So I get -2 times 2 is -4x. -2 times -5 is positive 10y. And -2 times 1 is -2. So I get that row, and then the top row is still 4x plus 3y equals 15. So I only had to tweak the bottom row. So multiply so it will cancel. So we did that multiplication to get it so that when we do our addition step, stuff actually is going to cancel. You can see that the x's cancel. So we don't get anything for the x's. That's empty. And then we can do the rest. 3y plus 10y is 13y. 15 minus 2 is 13. Divide by 13 both sides. 13. I get y equals 1 is our y part, half the answer. But that's the idea. So if stuff doesn't cancel, you can always multiply and make it so something will cancel before you add. But again, I give people problems like this all the time on the test, and people just try and add it after that, and then try to figure out what to do, and they're stuck. So you got to remember, you got to multiply to make it cancel. You could go back and use substitution, and substitution works just as well on this. So if you like substitution, go ahead and do it. But you should know how to do this, how to multiply and make it so it'll cancel, because yeah, that's something that's important to know. Okay, let's go ahead and plug y back in. Again, I can plug this in any of these equations, doesn't matter which. I'll just go ahead and go with the top one because it's nice positive numbers again. So I'll put y into there, so 1 for y. So we get 4x plus 3 times 1, because y is 1, equals 15. This one is just 3, so it's just 4x plus 3 equals 15. We'll subtract 3 from both sides. So get rid of this 3 here. So we got 4x equals 12. Next thing, I'm going to go ahead and divide to undo that multiplication. So go by 4 here, and I get x equals 3. So there we go. We got our x, we got our y, so that's our answer. Our answer is 3, 1. And again, if you're really double stuck, or if you're a multiple choice, you can always go back and take that and say, does it work? 3, 1, plug 3 in for x, 1 in for y, and double check and make sure it actually works out. Okay, one more of these multiplication ones. So again, to make this work, we're going to have to multiply. Now, if you look at this, you're like, okay, well, wait, what do I multiply by? Because to make 3 and 2 match, there's not a nice number I can multiply 2 by. To make 3 and 4 match, it doesn't work to multiply by 3 by a nice number either. So a trick on one like this is you actually just multiply both equations. So there are problems where you might have to multiply both. You can do it with fractions instead, but who would want to do fractions? So instead, we just multiply both equations. So I look at this, I decide, do I want to get the x's to match or the y's to match? And it works either way. I'll go ahead with the x's just because I can work with smaller numbers that way. So I'm going to multiply both the top and the bottom by a number. I do need things to cancel. So I'm going to multiply the top by 2, but I'm going to multiply the bottom by -3. That way when I multiply, 3 times 2 is 6, but 2 times -3 is -6. And that way stuff cancels. So I'm going to do the top row. 3 times 2 is 6x, 2 times -4 is -8y, and 2 times 11 gives me 22. Bottom, -3 times 2 is -6x, -3 times 3 is -9y, -3 times -4 is +12. So I multiply everything through by the negatives, got those expressions. Now we can go ahead and add things up. 6 plus -6, those cancel, that was the point, right? We want the x's to cancel. -8 plus -9 is -17y. 22 plus 12 is 34. Undo multiplication by dividing. You always divide to undo multiplication. Divide by -17 to cancel that. Get y equals, so this gives us -2. 34 divided by 17 is 2. Positive by negative is a negative. Once we have our -2, we can plug it back in. You can actually even plug it in these equations. Still work. It doesn't really matter which. I, again, usually pick one of these ones that I think is going to be easiest. So I'll go ahead and do the top one again. 3x minus 4 times -2 equals 11. -4 times 2 is +8. 3x plus 8 equals 11. Subtract that 8 across. I'm just trying to get this x by itself, so get rid of the 8 part. 3x equals, that gives us 3. And then divide to finish it off, so divide by 3. Get through this 3, and we just get x equals 1. So we can see our answer, our ordered pair, again, x first, so 1, -2. So 1, -2 is our answer. And that's the hardest, really, the addition get, except for maybe if you have one where you have to rearrange the stuff. So all the ones I gave you, I've kind of put the x's, y's, and numbers in order. You don't have a problem where you have to sit there and rearrange it to make sure the x's and the y's and the equals and all that were lined up. But otherwise, multiplying both rows is kind of the hardest they get. Now there's actually one more way to think about these and one way to solve them, and that is with the fact that these equations we're solving are all equations of lines. And one way to solve this is just to graph and look at where the lines intersect. Because remember, when you graph a line, you're actually graphing all the solutions. So these ordered pair of solutions actually really have been points on a graph. So first off, this chart right here just kind of shows you the different potential solution sets you could have. So first off, you can have something with just one solution. That's the most common thing, because anytime you have two lines that intersect at one point, that is going to be, one solution. So that's what happens right here. We have one solution because they cross at one point. And that's the most typical answer. Everything we've done so far has been that kind. Now it is possible to graph two straight lines using two equations and never have a solution. You can have one with no solution because the lines are parallel. So if you have these parallel lines like this, they will never cross because their slope matches. There's no solutions to those. Last thing you could have is you could have two lines that are identical. And if the lines match, if the two lines are the exact same line, then there are lots of solutions to the pair equations because every single point on the line is a solution because it's on both lines. So you can actually have all three options. If I give you two equations, you could have two equations where they only intersect once. Everything we've done so far is like that. You can have two equations where they never cross, no solution. And you could have two lines where they are the same line twice and they have infinitely many solutions. So you can actually solve all these pairs of equations I've been giving you just by graphing both lines and seeing where they cross. Now, if they're solved for y, that makes it pretty easy because they're already in slope-intercept form. So you can see something like this: y equals negative 2x plus 5, negative 2 is your slope, 5 is your intercept. So that's pretty straightforward. You can graph that. If they aren't solved for y already, then you have to think about making sure you get them solved for y so you can find that slope and the intercept. So I'm going to do that for the second line. I'm going to go ahead and solve for y first because that'll make it easier to graph. So let's go ahead and do that, and we'll solve this one for y. So we've got 3x plus 2y equals 6. So first off, I'm going to subtract 3x across. And I'm trying to get this y by itself. So I get 2y equals, I'm going to put the 3x first because I like to have it in that slope-intercept form where I have slope first and intercept at the end. Last step, to undo this multiplication, I'm going to divide by 2. Make sure when you divide by 2, you divide everything on both sides by 2. I always get people that try and divide just half of this side. Since I divide this whole side by 2, I have to divide this whole side by 2 as well. So here the 2's cancel, that's why I get y by itself. Over here I get negative 3 divided by 2, which is a fraction, so I get negative 3 halves x. Here 6 divided by 2 gives me 3, so I get negative 3 halves plus 3. Okay, so that's the equation I'm going to graph. This equation I'm going to graph. So I'll go ahead and make a little xy chart, so xy graph. Put some points on it, so 0, 1, 2, 3, 4, 5, 6, 7. Got 1, 2, 3, 4, 5, 6, 7. I think that's all I need to graph it. So let's go ahead and do the two lines. I'll do this one in blue, actually. Do this one in blue. Okay, to do this one, my intercept's 5. So I got 1, 2, 3, 4, 5 is the intercept right there. And then my slope is negative 2. Remember, you can always think of slope as a fraction, so negative 2 over 1. I'm going to go down 2 because it's always rise over run. So negative 2 is down 2 and then run 1. Down 2, run 1. Down 2, so it's going to be that point here. Run. So it's going to look like that. So, yeah. So it's going to be a line. Looks like this. It's not perfect because I'm drawing it by hand and stuff. I think if I go a couple more points. So down 2 over 1, down 2 over 1, I think there's a point right there. I think that should be enough points. So you can kind of see what it looks like. That's the line. This is y equals negative 2x plus 5. Let's graph the other line. So we're going to graph this line over here, this negative 3 half x plus 3. So it intercepts at 3. So go 1, 2, 3. That's the intercept for that line. Its slope is negative 3 over 2. So I'm going to go down 1, 2, 3, but over 1, 2. So it's going to be right there. Go down 1, 2, 3 over 1, 2. It crosses right there. So that actually is where they intersect. So if you draw both lines, you see that they cross like that. And so that's the line y equals negative 3 halves x plus 3. So that's their intersection, which is the point 4, negative 3. So 4, negative 3 is a solution. And you don't have to do this by hand. I did it by hand, but I could have just typed both equations in my calculator, right? So I could go in here, type in negative 2x plus 5, enter, type in the other equation, so negative 3 divided by 2x plus 3. Graph those. My zoom's all messed up because I was using it for stats class, so let me fix that real quick. Probably shouldn't have to do this, but hopefully yours isn't messed up. And I'm going to just zoom 6, which is a nice standard zoom. Okay, so everything should be working now. And it should be able to see where it crosses. You can see that they do cross over at 4, negative 3. You can use the trace key to kind of get close to where you think it's going to cross. So here I get close and it looks like they're crossing about there, and you can see how that's 4, negative 3. So if I type on 4, negative 3. And you can actually jump between lines. If you use the up arrow, you go from the blue line to the red line. So you can see that if you type 4 in on the red line, you also get negative 3. So that's one way to double check yourself, is just to go to your calculator and then jump back and forth between which line you're on, and make sure you can find that same point on both lines. So graphing is a way to solve it. Now I will warn you, graphing is not always the best way, because if the answers have any kind of fractions or decimals, if the answers have really big numbers that are hard to find on your graph, then graphing is not a great method. Now if I give you nice, simple, easy problems with just whole numbers, then graphing works fine. So I'll just warn you maybe not to try to do every single problem from graphing. But yeah, graphing is a valid method. So if you get to the test and I ask you to solve one of these and you graph it to solve it, that's fine. Just make sure you'll have to solve both of them for y before you graph them. And if you do solve with graphing, remember to always draw your graph on the exam so I know what you did. Because if you just say I graphed and give me an answer, I don't have any work to show. You're not going to receive full credit. So your work to show if you use a graph is to actually draw the graph and show me how, what the two equations look like and where they intersect. Okay, before I'm done, I do want to show you a couple of these weird ones, the ones with no solutions or infinite solutions. I just want to show you what those look like when you're solving them. I'm going to do them not with graphing, because graphing you can pretty quickly see that if you graph them, you'll have two different lines or the two of the same line. But I'm going to go ahead and do these for the other methods. So I'll start off, I'll do the first one with substitution, because it's already solved for x. It's a good candidate for substitution. So let's do this one with substitution. You could use either method, right? You could use addition or whatever, but I'm going to go ahead and use substitution. To do that, I'm going to take all this stuff and plug it in for x in the other equation. So I get 9 minus 2y plus 2y equals 13. So I plug that all in for x here. Okay, and then I got to solve. So I go ahead and go to solve, and I say, okay, negative 2y plus 2y. Well, I notice that when I add those together, they cancel, right? Because negative 2y positive y are opposites. So I end up with just 9 on this side and 13 on the other side. And you notice that at this point, I'm stuck, right? I can't solve for y. In fact, not only am I stuck, I have an equation that you can see pretty obviously here now is not true, right? This is not true. This is false. You can't make 9 equal 13. So if you're solving a problem, and you're doing addition method, substitution method, whichever, you're solving a problem and all the letters cancel on you, you end up with no letters anymore, and you end up with an equation that's false like this, what happened is you actually have a pair of parallel lines. These are parallel lines. Now, no matter what you do, you cannot find a solution that works. So when you try to do substitution or addition method, you end up with a false statement because there's no way to make this work. So when you get a false statement like this, there are no solutions. These parallel lines will never cross, and therefore there's not going to be an answer. So if you ever do that, if you graphed them, they'd look like this, and you can see that they never cross each other. If you found the slope for both of these, if you solve for y and find their slope, they have the same slope, but they'll have different intercepts that won't cross. Okay, let's try the other one. This one I'll go ahead and do with addition, because we did substitution last time. Again, it doesn't really matter which method you use, but I'm just going to show you both. This one, to do addition method, we do need to rewrite it a little bit. First off, we need to switch stuff around. So I'm going to flop the top one around so that the left and the right are switched. So we end up with 3x minus 5 equals y. So I'm just switching which sides. You can always switch sides on the equal sign. That way it's more closely lined up with the bottom. So we're looking a little bit better. Again, you have to have the x's, the numbers, the y's, the equals, all that has to be lined up. Next thing, we need things to cancel. So I'm going to multiply the top equation by a negative 7. So if I multiply by negative 7 here, the x's will cancel. I'm going to multiply by negative 7 on the top. So negative 7 times 3 is negative 21x. Negative 7 times negative 5 is positive 35. 7 times y is negative 7y. So if I add that with the bottom row, so I take those two and add them together, then you can see that the x's would cancel, the y's would cancel. In fact, the zeros cancel. You end up with nothing on the left, so 0, nothing on the right, so 0. You end up with an equation that is true, right? That equation is very true. 0 is equal to 0. But it really didn't matter what x or y was because everything just canceled and ended up with an equation that's true. This is what happens when the two equations are the same equation. Now, they don't look like it. If you look at the beginning, you say, okay, they don't look the same, right? This one's got y, this one's got 7y. Well, if you stop and notice, though, if you take the top one times 7, you get the same as the bottom equation. They're just switched around, right? So if I had multiplied by a positive 7 instead of negative 7, the equations would match exactly. So these ones are the same equations. And it's possible to make two equations look really different, but they are the same equation. And that will happen. You'll end up with an equation like this where the x's and the y's cancel. You end up with a true statement. 0 equals 0, 1 equals 1, 2 equals 2, something like that. You end up with a true statement, and that'll tell you that there are infinitely many solutions. So basically, any point that is a solution for this equation, for the one equation, is a solution for both equations because they're the same equation. So you'll have infinitely many solutions. Okay, so that's it for this section. Like I said, you can use addition method, you can use substitution method. I don't care which method you use because they both work all the time. If you want to graph it to solve, that works. Again, sometimes there are times when maybe it's not as handy, but most of the time it works fine. Just watch out for those no solutions, infinitely solutions, because those will pop up. So the next set of notes, we'll just look at what happens when we have 3 variables instead of just 2. And then we're done. That's our last set for the semester. So I'll see you on the next set.